culture, technology, processes. These are three of the levers executives have when they want to steer an organization. From those three, technology is probably the easiest to change. Processes, medium hard, and culture, also known as the way we do things around here. Well, culture is the hardest one to change. And if you happen to be in charge of an engineering organization comprised of engineers, the highest opinionated creatures amongst the human species, well, culture happens to be extra hard to change. Hi, everyone. My name is Christine Andonoff. I'm a solutions architect at AWS, where I guide organizations on how to evolve their Kubernetes platforms. And today, we'll talk about how you can evolve your Kubernetes platform so you can do balanced organizational changes in the future. First, let's talk about what an unbalanced organizational change is. It is when all three levers are pulled to the highest. And you probably know what it feels like and what it looks like because you had to do those changes in the past. You had to do one of these when you were migrating to the cloud. Probably you started with a couple teams, gave them access to the AWS console. They were creating EC2 instances. Quickly but surely, security and compliance got involved and say, hey, developers cannot have access to the AWS console. And then you started migrating to containers. So now you have your EKS platform, your ECS platform, and everybody in the large organization still has their on-prem. And what happens with organizations is you acquire companies, and they come with their own platform. And that might be serverless. And over the past 5 to 10 years, with the rise of AI ML, well, now you have your data platform as well. This is a very simplified version of where we find our customers. On average, they manage about 7 to 8 different platforms. And what does everybody do? Well, they look at this and they're like, we're gonna fix it once and for all. We're gonna set a centralized platform team, and the centralized platform team gets together and they're like, okay, we're gonna standardize. We're gonna standardize on Kubernetes because it runs on multiple clouds. On-prem might be already running Kubernetes. And the ECS platform, well, probably that's kind of easy to migrate to Kubernetes because it's containers. But how about the Lambda? And how about the ML platform? And even if we are able to standardize on the runtime and migrate everybody, what is that future platform going to look like from developer experience? Well, we kind of know what it's going to look like. So let's talk about, in that future state, what it would be, how a developer will create a microservice and a database for that microservice. Usually, they will call some pipelines. They're going to go and call the networking pipeline, grab the output of that pipeline, get security group ID, VPC ID, things like that, and pass it to the data pipeline. Hopefully, security worked together with the database team here. And not only that pipeline would give us an RDS database, but it also would give us credentials to access that database. So the developer would then grab the RDS endpoint and the secret and pass it to the Kubernetes pipeline. And hopefully, they got all this working the first time, and now the microservice can access the database. Do you know what that developer does next? Well, they sit around and wait, and they watch that database. Because at any time in the next few hours, it can go poof and disappear. Because the compliance team set a continuous compliance tool on that account, and if it disagrees with one of the settings of that database, it would just wipe it. So to take a step back here and evaluate these pipelines, why are we in this situation? Well, with pipelines, they're not composable. See, we don't have a standard mechanism to take the output of one pipeline and pass it to the other one. They're not self-healing. If that pipeline fails, as a developer, I'll re-trigger it, and the next thing I need to do is go set up a meeting with whoever created the pipeline, or open a ticket for them. Pipelines also don't have a single source of truth state. And you can argue here and say, but Terraform has state. Yes, it does, and that's the state of the pipeline, not the state of the database. So if the database pipeline created the database, and if the compliance pipeline went and deleted, where is my source of truth? I want to know, is my database up and running? I don't care what the state of the pipeline is. So if this was one microservice with one database, it would take probably that developer like, what, half a day to get it all working, and that's fine. If you're not moving anything, if you have to do this once in a blue moon, sure. But if you're expanding to new regions and you have to deploy all your applications, that is all hands on deck, months of, like, the whole development holds down and deploys to new regions. How about if you have to migrate a mainframe into AWS? How many developer hours? Well, I think we need a new unit. How many developer lifetimes do you think that's going to take? And we can keep investing in this approach. We can duct tape it all together with shell scripts and custom code. But I'd say, are the pipelines even the right approach here? Shouldn't we use something else, like APIs that are composable, self-healing, and provide us the state? After all, the whole internet works on APIs. Like, if you come to AWS to open an AWS account, you're not going to go call 4 pipelines. You're going to call an API. And that API will give you the account. And if maybe an error of, hey, you mistyped your credit card, go type it correctly. And we've changed over the years that API many, many times without you even noticing. Well, unless we change the UI, but you get the idea. So why don't we use APIs to provide as the interface to our developers to create infrastructure? Well, for once, if you were to create an HTTP API, if you were a developer and you were to create an HTTP API, every programming language, I can say it has at least 5 frameworks to create HTTP APIs. But we don't have a framework for APIs when it comes to infrastructure, to cloud infrastructure. A while back, about 5 years ago, with Kubernetes 1.16, CRD's custom resource definition graduated to GA. And a few large organizations took a look and they're like, can we use that to be our framework for APIs? It gives us RBAC. I don't have to create the permissions from scratch. It gives us a reconciliation loops and mechanics out of the box. And we have a few customers that did this successfully, but it turns out this is very, very hard. And the reason why it's hard, it doesn't have to do that much with the technology, as it does with the people who create the technology. See, the majority of platform engineers, they know how to operate Kubernetes at scale. They know how to operate open source projects. They know how to operate infrastructure as code tooling such as Terraform, CloudFormation, and so forth. But writing custom controllers is not their cup of tea. Developers, on the other hand, are the mirror image of that. They would love to spend their day in code, and their day-to-day job description is not to test Terraform, troubleshoot Terraform pipelines. And of course, you're going to say, but Christina, there are these platform engineers who write controllers, and they're those developers who know their Terraform and they love it. And yes, they are. It's just there's a very few of them. And if they create this platform, somebody has to support it. The majority of the platform engineers have to support it. So recognizing this, about 4 years ago, AWS created this open source project called ACK, which stands for AWS Controller for Kubernetes. We were like, okay, we know everybody needs an S3 bucket. We know everybody needs an RDS database. We are going to create these controllers for you. You don't need to create them. With that project, we did a few things right, such as we decided that each and every service will have its own controller. So the S3 service will have the S3 controller, RDS service will have RDS controller, and so on. Back in the day, we also decided that each and every service team within AWS will take care of their own controller. And that didn't turn out so well, meaning some of the controllers were really well maintained, while others suffered from that particular team's attrition, business priority, whatnot. Earlier this year, recognizing that, the EKS service team took ownership of all the controllers, and today we have 50 controllers. All 50 are GA as of yesterday, and what GA means for you is that it means they're covered by your enterprise support. So if we were to use ACK to deploy a service plus its database, we'll probably install a few of these controllers. In this case, the S3, the AKS controller, we need that to set up the pod identity, and the IAM controller. And that would provide us the APIs to create an S3 bucket, role policy, and to connect all these. We still, though, need yet another construct here, because that's not enough. We find that that's not enough. We need a way to combine these resources and abstract the complexity away from developers. We need to be able to do logical operations between those resources. We need to be able to pass strings or errands from one resource to the other, and we need to put some conditionals. And we can't do this with Helm, because Helm only takes us so far. And the alternative to do that is, well, writing a custom controller. And we just talked about that. That's straight up unicorn business. So it's been a while. Do you think it's time for something better here? I think it is. We have been working on this open source project called CRO that will serve as the all-purpose glue for Kubernetes resources. And I think that CRO is the last missing piece of the puzzle for us to utilize the Kubernetes resource model in order to build our platforms on it. For developer interface, well, this is the developer interface. That's what they use usually to deploy applications. And in fact, they're very happy with it. And using CRO, what we can do is we can just add like S3 enabled through. I don't need to know the complexity behind an S3 bucket. Just give me an S3 bucket. And then as it comes to the platform team interface, what the platform team can do is install CRO in their cluster. And when you install CRO, what it gives you is one CRD in your cluster called the resource group. And using that resource group, you can group together these constructs. You can abstract the complexity away, you can pass values and do logical operations. And you can do that for any APIs that are available in your cluster. And as I mentioned, when you install CRO, you get a resource group API. So now you have a resource group API, and you can even group resource groups with higher level constructs. And then developers can have this interface and instantiate those resource groups. So I think it's time to demo crawl. But if I hand off this clicker to Amin here, I'm sure he'll introduce himself as, hi, I'm Amin. I'm a software engineer on the service team. And I decided that I should give him a proper introduction. See, he told me about crawl, we've talked about it. And earlier this year, I met him for the first time face-to-face at a conference. And we started really talking about it. We spent 4 hours in the hallway of the conference. And I got so excited about it, I felt like a kid in a candy store. And I want you to have that very same experience and experience that joy from the one, the only, the creator of Crow and one of the core maintainers. Take it.
My name is Amin. I'm a software engineer at the EKS service team. And right now I'm going to be doing a live demo of Crow. So things could go wrong. If they go wrong, we can fix them on the way. So typically, when you want to deploy an application in Kubernetes, what you have to do is to create a deployment, a service, an ingress, at least to expose it to the world. And what you typically have to do is let's look at home. So let's look at those bare files in my application. Typically, what you do is you create a deployment like this, a service, and an ingress. And if you really want to group these resources together, there are a few ways of doing that. One of them is using Helm, for example, and templating. Or you could also use something like Customize. If you're really brave, you can also build your own controller to do these kind of things for you, and it's completely possible. You can really expose those resources as a CRD in your cluster, or you could use Crow. So here, I'm here today to show you how to instruct Crow to be your controller, to manage your custom applications without really having to touch Helm, customize, or build your own controller. So let's take a look at what the user will have to deploy in order to have those three resources. So let's say the user will have to create a web app, and all you want them to do is to provide basically a name, a port, an ingress, and maybe an image by default that is here. It's Nginx. So in order to instruct Crow to start serving this CRD for you, all you have to do is to submit a YAML file that configures it to create a CRD for you called web app and start serving applications under the hood. And in this case, all we have to do is to create something called a resource group. And a resource group is just another CRD in Kubernetes. It's the entry point for you to configure Crow to start listening to new objects and manage applications under the hood. It's pretty straightforward. There is only one thing, or two things to do under the hood. The first one is that you want Crow to manage a CRD for you. So here you can say hey, I want a CRD v1 alpha 1, and I want the kind to be web app. And if you're familiar with Kubernetes, there is this concept of Open API schema. Whenever you want to build controllers, you have to define those CRDs in Open API schema. This is exactly Open API schema, but in a much more lighter and simpler way. You can see here that we want the user to provide a name, a namespace, an image, a port, and whether they want to enable the ingress or the service as well. And we want also to instruct Crow to publish back some fields or some information to the users. So when the user only looks at the web app, you want them also to see the deployment conditions and the deployment available replicas and the ingress, for example, host name in this case. What you're seeing here is cell expressions, or also known as common expression language. Common expression language is a language that got introduced to the API server very lately. If you're familiar with webhooks, validation admission policies, or mutation admission policies, it is a language that is very similar to JSON path. It's very simple and straightforward to write. It is portable, safe, and secure. Now that we instructed Crow to manage this CRD with this specific shape for us, we can also tell it, like, hey, you know what? Whenever you see a web app, I want you to go and create a deployment. And again, using the same language, CEL or cell, you can be like, hey, you know what? Take the user input, the spec.name, and inject it in the deployment.name. And you can do the same thing with the replicas. Like, hey, I wanted to use the user spec.replicas in the deployment. And so on. You can do the same thing with the image, the ports, and let's say if we had an S3 bucket, I wanted to inject the S3 bucket name as an environment variable in my deployment container. Now that we have a deployment, next what I want is a service. And typically in Kubernetes, when you create a service, you also want a selector. So basically, what we can do here is like we can create a selector to point to the same label that the deployment has. Now let's create the ingress. And now this is where things get interesting. Because now you don't really want to point the ingress to the wrong service. And what you're going to do in here is that you're going to instruct Crow to pick the service metadata.name and inject it in the ingress service. And what's happening under the hood in here is that you're telling Crow that ingress depends on a service. And there is a dependency between the two. So Crow sees this relationship and understands that it needs to create the service first, wait for it to be in a specific state, and then go and create the ingress. That's it. That's all you have to do to instruct Crow to be managing 3 resources together or group them together as one unit. So now, if I go and describe my resource group, let's look at the name of this one. So this one is going to be web app crow.run. If I do get resource groups, -o-wide, you can see that Crow tells you that it's active, and it's managing a web app, v1 alpha 1 CRD, and it also gives you the topological order. It's really like very aware of how things should be created, maybe in a specific, maybe in a very different order than the one that you provided. If you started with an ingress and finished with a deployment, Crow is able to understand that it's not the proper order, and it's going to correct that. Now, let's look at the CRDs. So if I do show me the CRDs that are managed, like maybe one that is named web app. So you can see here, should arrive very soon. Okay, I think internet is slow. But now we can see that there's a CRD managed by Crow that was created. And if we inspect it under the hood, you're going to see that we have a lot of fields that you typically do in CRDs when you're like managing CRDs. This is the original open API spec that you have to provide in order to create something like this. While in Crow, we've done it in a very simple way that is also just open API schema under the hood. Anyways, now that we have the resource group registered, all we have to do is submit something like this. And Crow under the hood is going to create a deployment, a service, an ingress for us, and use those like test app2 here and the port 80. Now let's take it to a step further. What if I wanted also an S3 bucket or a database or something in AWS? You could use controllers like ACK, and you can do things like in ACK, S3 buckets are very simple to manage. You can see here in this case, we have just a CRD, again, called bucket. And under the hood, the controller will take this. And in the status, you can be like, hey, I want the S3 ARN to be published back to the instance. And I want to see if what's my IAM role ARN. Similarly to an S3 bucket, you can also instruct ACK to create an IAM policy for you. It's very similar to how you do things in Terraform or CloudFormation or I don't know, Customize, for example. You just like have to precise a name and a policy document. Similarly to the S3 bucket, now I can also create a pod identity. And if you're familiar with the pod identity, is a new API that EKS published last year that lets you basically configure IAM permissions or like give IAM permissions and credentials to your pods in a very streamlined way. In this case, what we're going to do is like, hey, we're going to instruct Scroll again that there is a new abstraction called pod identity. And what it does under the hood, it creates an IAM role, it creates a pod identity association, and it creates a service account. So now, again, we're abstracting those things from our users, and we can literally just group our deployment service ingress, pod identity, S3 bucket, the IAM roles, everything into one stack. And we can call that the web stack. So we can look here at the web stack resource group, and you can see that we're under the hood, we're using the web app that we defined before. We're using also the pod identity we just like showed a little while, and the S3 bucket here that is also going to go create the IAM roles and a few things under the hood. So now what we did is like we instructed Crow to basically show us or like orchestrate the creation of many resources under the hood. And if you see here, if you ask for the topological order, you can see that Crow has a very good understanding of what to do with each resource. So I'm going to try to create one instance of this web stack. It might take a while to get created. It might go wrong, but we're going to give it a shot. If not, we also like have one that is ready to show. So what I have to do as a user, basically, to create all this stuff is just exactly to request a web stack instance. So that's going to be something like this. All I want is to provide an image, a name, whether I want an S3 bucket, a service, or an ingress, and that's all. Everything else should be handled by Crow. And since this is like a new demo, I need to modify the name of the instance, because Kubernetes will just go ahead and treat that as the same resource. So in this case, we can do like, hey, this is reinvent test app 2, and then we can give it, let's do here, awesome. I think that's all we need. So we can go ahead and apply this instance in here. So we have the new CRD. Crow configured itself already to start watching for all these resources, and it's going to unfurl itself into multiple other resources that are going to all get connected to each other. And at the end, all we want to see is, for example, an ALB endpoint that we can show in here. So if I show web stacks, cool, we have an error, which is good. Because now Crow is going to realize that there is an error under the hood, and it's going to keep reconciling. Because it's a controller, it's Kubernetes, that's the concept of Kubernetes. We want to see an error, and Crow is going to try its best to literally just like glue everything together and make sure that it works. So let's look at under the hood what's happening. Let's see if we have an S3 bucket. So if I do get kubectl get buckets, I'm going to see that I have the new bucket that just got created 51 seconds ago. If I look at the IAM roles, so in this case, you can see there is another like new IAM role in here with the awesome tag. And if I do a pod identity association, I should see a new one as well. OK, cool. It means that Crow is still working towards deploying everything together. And if I do get pods, maybe that's what we're missing. No, actually, the pod got created. So let's look at the ingress. We have a new ingress, and we have an endpoint. And if we look at the web stacks, so now Crow fixed it, actually. They realized that something wrong happened. Maybe it was like a delay in the APIs or something that didn't get connected together. But Crow retried until everything was fully synced. And at the end, it provided an ingress endpoint for us. But I don't have to look at the ingresses to find the endpoints. All I have to do is look at my web stack. I can look at the status of the web stack. And Crow is responsible of publishing back this URL to me in here, telling me like, hey, the URL of your web stack is this one. And your deployment conditions are this one. And this is the S3 arm of your the arm of your S3 bucket. So if we take this one in here and then we open it in a browser, OK, it didn't propagate yet. And this is why I tried to deploy an application before this, because it's going to take some time. So what we can do in here, we can look at the first one. We can get the endpoint of the first app. And that's going to be this URL in here.
It's the HTTPS.
Oh, I use the same one. Good catch. Should be this one? Ah, yeah, this app too. Yay, debugging together. So this is the new ALB, the old ALB endpoint that I just provisioned before the session. And you can see here that I have an application that got created in my EKS clusters. And under the hood, there's an S3 bucket that I can just go and upload files to. So I can say here, hey, this is my hello world. Reinvent is awesome. I can add this. And this is basically got added to my S3 bucket. So yeah, this is like a demonstration on how Crow can really orchestrate the flow of a lot of resources under the hood. So why would you even do this? The thing is that we all love Kubernetes. We all love building CRDs and APIs and use the kubectl command line. It's super cool to use. The thing is that when you use Crow, you get a lot of things out of the box. You get RBAC, for example. You get namespace isolation. All these things, Crow works with them very, very smoothly because it's just like the Kubernetes ecosystem. So what are we missing in here? Maybe we need a kubectl plugin. So that's what we're doing actually today, and I think this is going to be released in this week. So what we have is a Crow CLI, or it's a CLI, but it's a kubectl plugin. And you can do things like, hey, I want to see all the instances that are web stack.
Crow.run.
.run, yeah. And you can see here, Crow is telling you not only that there is an instance, but there's also the sub-resources of everything. And you can see that I can see my reinvent test app2, the S3 bucket, the pod identity, and the web app. And you can also dive deeper by saying hey, I want to see what's under S3 bucket. And inside here, you're going to see two resources. So there is an S3 bucket and the IAM policy. So now that you can see these resources, what else can you do? Maybe you need very restricted RBAC for those specific resource groups. The last thing you want to do is give Crow a lot of permissions to manage anything in the cluster. You really want to narrow down to just to manage the resource groups. So you can use the Crow CLI to generate RBAC for you. And you would do that with a very simple command line hey, generate RBAC. And I want my, in this situation, here is my resource group. Let's do white queue. And you can see Crow here is telling you directly, here is what I need to manage a web stack application for you. I need an S3 bucket access, pod identities, web apps, and all the verbs that it needs to manage those applications. And you can do the same thing with S3 bucket. It's going to tell you, like, hey, I need IAM access, for example, ACK IAM access and S3 access in order to manage these resources. OK, cool. What else can we generate? Like, let's say your developers or like your platform team created a lot of resource groups for you, and you really don't want to spend a lot of time generating those instances. You can ask the cross CLI to emulate some for you. For example, in this case, you can be like, hey, I want you to generate an instance. And it's going to tell you, like, hey, your instance should look like this. So it's going to give you the kind, the name, the namespace, and an access and a name with dummy strings. And it literally is going to, you don't need to create everything from scratch. You can see examples of everything under the hood. So, OK, now that the cross CLI can help you generate a few manifests to manage RBAC and instances, it would be very nice if you could just take those resource groups, put them in ECR, and distribute them to all your teams, for example, or store them as like, this is my standard way of how I create applications. And this is what we just did, actually, very recently. You can, very similarly how you use Helm command lines, you can do something like this. When you want to like authenticate with Helm and say like, hey, I want you to log into this registry. For this demo, this is my personal AWS account. And I'm trying to authenticate Crow to this ECR URL. Very similarly to Helm, you can just do AWS ECR get login with the Crow CLI. OK, now that we have this, the Crow CLI login in, we can go and package our resource groups. So we can do, go ahead, and I want you to do the web stack resource group, and I want you to put it in, let's say, webstack.tarball. OK, cool. And you can see that here that there will be a webstack.tar. So I'm not going to open this file, but you can imagine under the hood, this is an OCI compliant image that we can store in ECR. So we took the resource group, put it in a tarball. Now you can publish it in ECR and just distribute it to your teams. So let's say I'm a platform admin, and I want to publish this to ECR. All I have to do is take this, this URL in here. Actually, let me do a go run. OK. So this is my tarball. This is the URL. I'm going to like just say kcrow publish. The tag, let's say it's v1, and then the file is going to be the webstack.tar. And this is the, I think I have one called dev. OK. Yes. It's the first time, by the way, I'm like packaging this web stack in here. So you're seeing a true live demo. OK, cool. Now you can see that the Crow CLI pushed this tarball to ECR. And if you do it in ECR describe images, you can see that there will be a v1 tag on my dev repository. And now, instead of literally like pulling those images locally, I can just do a Crow install. So very similarly to how you use like other CLIs in the Kubernetes ecosystem, you can be like, hey, I just want you to go and install this v1 resource group. And let's do, let me make sure that we don't have the web stack resource group. So I need this URL. OK, this one. So if I do this, you can see that Crow successfully installed the resource group in your cluster. And if you do a get resource groups, you can see it got installed like 5 seconds ago. So not only you get a controller, but also you get a CLI. to manage your resource groups, distribute them to your teams, and you can leverage all the cool things in the Kubernetes ecosystem to do awesome Kubernetes.
Nice demo. All right, so now that we know what CRO is, picture patterns of what our customers want to use it for. We heard loud and clear that if you're doing a Kubernetes cluster per team, you want to provide an API for your teams to create Kubernetes clusters. And you can do that with a combination of ACK and CRO installed in a management cluster, and you can create other Kubernetes clusters. This is a very simplified diagram. In the examples, we have an example with VPC and the networking and the EKS cluster, and soon we'll have like how do you hook up those EKS clusters back to ArgoCD. Creating the secret in the management cluster. So then ArgoCD can have access to deploy web stacks in those clusters. For deploying applications, we recommend centralized Argo, decentralized CRO, and ACK. But also this depends on how your organization is structured. We know that some organizations don't do a cluster per account. We know that sometimes you give each team their own account and there's no cluster in that account. So depending on how your organization is structured, you can mix and match here and figure out the best way for you to install it and manage it. That said, CRO open sourced literally 2 weeks ago, and it's still under active development. That resource group API is an alpha API, and I want to warn you that using alpha APIs in production may cause unexpected side effects, including but not limited to sudden feature disappearance without notice, a potential overdose of debugging at 3 a.m., development teams experiencing loss of patience or random urges to rewrite everything. Proceed with caution, consult your therapist or local support group before deploying. So why am I saying this? What can you do today to get started? So we know building platforms and building these APIs is going to take a while. ACK, as I mentioned, we have 50 controllers in GA. 50 controllers is usually most of what you would need for your Kubernetes platform. And because they're in GA, you can start with building the ACK. What we're looking for as it comes to CRO, because it's under active development, we're looking for you to try it out, come back to us, provide us feedback, get engaged on GitHub, get engaged in the CRO channel in the Kubernetes Slack. And once you implement those APIs, actually implementing those APIs would be somewhat of a balanced organizational change for your organization, because we're changing technology, but we're not changing developer interface. So developer adoption is somewhat guaranteed. And you can build your platform foundation using infrastructure as Kubernetes APIs. And then once you get there and you provide unified platform for all your developers, you can start thinking about expanding the runtimes. In this new world of APIs, now we can cater to all the platform engineers because, as you saw, CRO and ACK, you don't have to program. It is as simple as writing infrastructure as code. So it matches the skill set of any platform engineer out there. We should collaborate with developers to make sure we present them with the interface that they want. And we invite all the unicorns to come and join us in developing CRO and ACK and contribute to open source. And once you we change to APIs, we'll be able to do things like this with your platform. With that, please check out our session resources. I'm going to keep this slide for a moment. And thank you so much.